Let's take a moment to talk about properties of exponents on rational numbers. We've used some of these exponents properties on whole numbers, but now that we're talking about fractions, we want to see if anything changes. I've got all of the properties listed out on the left from A to H. So there's a few properties here that we've seen before and maybe some that we haven't. We're just going to use these properties. I'm not going to spend too much time talking on where they came from, but that's definitely discussed in the book. So I've got a few statements written here, and we want to decide if it's true or false. So our first statement is a statement that claims that these two sides are not equal. So negative x to the negative 2. We're showing not equal to negative x to the negative 2. So let's check. Negative x to the negative 2, that's going to require us to use the negative exponent rule, b, which says that we can rewrite whatever is being raised to the negative power in the denominator with a positive exponent. So negative x to the negative 2 becomes 1 over negative x squared. And it's the entire negative x that's being squared, which means we could write this as 1 over negative x times negative x. When we multiply two negatives together, they make a positive, so this would become 1 over positive x squared. Now let's compare that to the right-hand side. So this is the left-hand side. The right-hand side will look similar, except for notice that it's not the entire negative x that's being squared, it's just the x. So then we would write this as negative x to the negative 2, or negative 1 over x squared. And at this point, we can see that there's nothing that's going to make those two things the same. They look similar. One is negative, the other is positive. So they're definitely not equal. This one is a true statement. Let's take a look at the next one. Now, what we just learned in the first one, you might say, oh, well, the next one's going to be false because we just learned that those are not equal. However, we're dealing with an odd number exponent. So again, let's look at the left-hand side. Negative x to the negative 3, that can look like 1 over negative x cubed. And if we do negative x cubed, that's the same thing as saying negative x times negative x times negative x. Two negatives together make a positive, but then if you multiply by one more negative, that whole thing results in a negative. So that would look like negative 1 over x cubed. I moved the negative up to the numerator so we don't forget that it's there, but you could have left it in the denominator, that's fine. I want it up top. If we had worked on the right-hand side, notice that it's just the x that's being raised to the negative 3 power. So negative x to the negative 3 would become negative 1 over x cubed, and these guys match. So in the case of an even exponent, if the negative is inside of the parentheses that the exponent applies to, then it turns into a positive with an even exponent. But with an odd exponent, you're going to have an extra factor with a negative, so the negative pops out. So although the first one was true where they're not equal, the second one is true and they are equal. Let's take a look at the third one. We have AB to the negative 1. We're showing it's not equal to AB inside of parentheses to the negative 1. For this one, we will use that same rule from part B. So if we look at our left-hand side, we can see that it's only the B that has the negative 1 applied to it. So we would write that as A over B. However, on the right-hand side, we do need to use the rule H. That says if the exponent is inside of parentheses, it gets distributed to each factor. So the right-hand side would look like A to the negative 1, B to the negative 1, or 1 over AB. And those two things are not equal. So this is true, they're not equal. Moving on to the next one, we have a to the negative 2, b to the negative 2. All of that's raised to the negative 1. Well, let's start by using h, but in reverse. So we're going to start with the right-hand side of h, and let's rewrite it so that the negative 2 is outside of the parentheses. So a to the negative 2, b to the negative 2. We can write that as ab, negative 2 on the outside. But we also have parentheses with a negative 1, so it would look like this. We don't really need the extra set of parentheses, but maybe it helps you see that we're really dealing with something like e. We have an exponent raised to another exponent, negative 2 raised to the negative 1. So that looks like ab to the negative 2 times negative 1, which is positive 2. And then using rule h again to distribute that, we get the right-hand side. So that would become a squared b squared. We have one left. Now this one's tricky because we have a sum here. We have a to the negative 2 plus b to the negative 2. That sum is raised to the negative 1. We could write that as 1 over a squared plus 1 over b squared. And then that is being raised to the negative 1. Well, to combine those fractions, we need a common denominator. That's going to end up giving us b squared plus a squared over a squared b squared. But remember that that's being raised to the negative 1. When a fraction is raised to the negative 1, we need to use the G rule, which basically says flip the fraction, make the exponent positive. So if we flip that, it would become a squared b squared over b squared plus a squared. And I think I didn't type up the problem completely because this is saying that it does equal a squared plus b squared, and that is not what we're showing here. So this should be does not equal. As it was written, it was false, but if we change that to does not equal, then it would be true, because they're not the same. A common mistake is to believe that this is true, and to try and distribute your negative 1 this way. This is not true. You cannot do it this way. A to the negative 2, negative 1, that does look like a squared. B to the negative 2, negative 1, that does look like b squared. The problem is that first step where I tried to distribute the exponent over a sum. We do not have a rule that allows us to do that. So these are not equal. They're only equal if you do the problem wrong. So if you do it correctly, like we did down here, you'll show that the left-hand side is actually equal to this, not to a squared plus b squared. Now that we understand negative exponents are essentially fractions, we'll be able to recognize when we're looking at numbers that don't look like fractions, even though they actually are. They're fractions hiding in plain sight. For example, 16 squared times 8 to the negative 3, this is a fraction. We're really looking at 16 squared times 1 over 8 cubed. 16 squared is really the same thing as 2 times 8 squared. And if we're multiplying that times 8 cubed, then maybe we want to distribute in our numerator so that we can simplify. So that looks like 2 squared times 8 squared. That's divided by 8 cubed. I can simplify my 8 factors. 8 squared divided by 8 cubed, that would leave one factor of 8 in the denominator. So we would have 4 over 8, or 1/2. 20 squared divided by 2 to the 4th, there's no fractions hiding in each one of these numbers, but 20 squared divided by 2 to the 4th is a fraction itself. 20 can be written as 2 times 10, so we replace it there. Distribute the exponent so that it looks like 2 squared times 10 squared. And now we can divide off the common factors of 2. 2 squared divided by 2 to the 4th would leave 2 squared in the denominator. We still have 10 squared on top. And if we can simplify this, we should. 10 is the same thing as 2 times 5. We should distribute the exponent of 10, so 2 to the 10 times 5 to the 10 over 2 squared. 2 to the 10 minus the 2 to the squared on bottom, that would leave us with 2 to the 8 on top and 5 squared. And we can leave our answer there because it says express your answers without negative exponents, and both of those are positive. Got 2 more, hang in there. 10 to the negative 1, that's the same thing as 1 over 10. 5 times 10 to the negative 2, that would look like 5 over 10 squared. Notice the 5 is not being raised to the negative 2 exponent, only the 10 is. Next, 3 times 10 to the negative 3, that would look like 3 over 10 cubed. And all of that is being multiplied by 10 cubed. We can distribute that 10 cubed into each one of those terms. So that would be 1 over 10 times 10 cubed plus 5 over 10 squared times 10 cubed plus 3 over 10 cubed times 10 cubed. And then we'll try to simplify. 10 cubed over 10, that would leave us with 10 squared. 5 over 10 squared times 10 cubed, that would leave us with 5 times 10. And then 10 cubed over 10 cubed divides off, so we would just have plus 3. And if we wanted, we could keep multiplying this. 10 squared is 100. 5 times 10 is 50. And then we add 3. 100 plus 50 plus 3, that's going to give us 153. And this is a great segue into our next chapter, chapter 7. So keep that problem in your mind because we're going to see that again. Last one, we've got a couple letters in here. Don't freak out. We're going to first start by distributing the exponent. So that would become x cubed to the negative 4, y to the negative 2 to the negative 4. I've got an exponent raised to an exponent, so that looks like x to the negative 12, and another one, y to the positive 8. We don't want negative exponents in our answer, so let's write our final answer as y to the 8th power divided by x to the 12th power. And we're done.